Hello, good afternoon, everyone. So I'll be introducing today the tool that's called Safe Schools Calculator. You can download this using the link attached to the tweet that I'll be posting. What's given here are the dimensions of the structure in terms of length, width, and height. Then you can indicate the number of occupants within that space. You can indicate the additional ventilation that you'll be introducing to that space. I assume 0.7 ACH if there are no windows or there's poor ventilation. I assume a value of 2.2 for open windows. So this is from a study in California. I also assume an ACH of 6 based on our simulation on the standard defect classroom. So this on scenarios where it's windy and the windows are open, so there's an inflow of air coming to the classroom. There's also outdoor CO2 levels. So if we're gonna mention green spaces or rural spaces, we assume an outdoor CO2 levels of 480. And same goes with the duration of stay. So if the class, for example, is being conducted for a total of 6 hours, we can plug it over there. Then of course we would be mentioning or indicating what kind of protective layers are the students and the teachers are wearing within that classroom. So we're gonna assume only cloth mask, surgical mask, KN95 mask, and N95 mask. Another provisions that we will be introducing in our recommendations is either putting up exhaust fans within the walls or as an adjunct, electric fans pointing to the windows, so serving the same. So we could be indicating the flow velocity of the fans, the fan diameter of those fans in terms of inches, then the number of fans that are pointing towards the windows. Then in the epidemiological perspective, of course, we will be considering certain scenarios. So for example, if the infected person is asymptomatic, so if he or she tends to be speaking only within the classroom, so we can indicate that. If there's a symptomatic person there, so of course we can indicate that there's coughing and so on. And also included are these cells here, which can indicate the CADR of the air purifiers that you'll be putting up within those classrooms, especially in air-conditioned environments. You can be also indicating how many of those filters are you installing within those classrooms. So that's the first part of the simulation, what this tool is all about. So those are the input parameters. The output parameters include the lookup table. So this is the matrix for the probabilities of infection and the reproduction number. So overall, what you will be actually looking at is this part here. So this will indicate the CO2 accumulation within that classroom. It will tell you if the classroom is well ventilated or not based on the standard of 1,000 parts per million imposed by ASHRAE. And of course, in terms of COVID-19 risk, you will be also determining the average daily attack rate. So that's your probability of infection, and this is the reproduction number. So if there's one coughing case, how many people will be infected in that specific scenario in the classroom, given those parameters that you've given. Now we move on to the intervention. So when speaking about interventions, it's actually divided into 5. So first is with the communication. So the communication is the existence of this very calculator that will communicate to you the risk that is being present within the certain scenarios that you'll be exploring. So given, for example, the sizes of the room, so we assume this to be constant. So of course, this is geometric, and this is the scenario that you'll be exploring. So if, for example, a depth classroom with this certain length, width, and height. And for example, total duration of class, initial total duration of class is 6. And you assume an outdoor CO2 of 480 in urban areas, but the rooms, perhaps we assume open windows, for example, we let diffusion do its thing. in dispersing the CO2 levels. And for example, we don't put any fans yet. So with that given scenario, 30 students over a duration of 6 hours, if there's one coughing case, almost all of the students are infected. So 28 approaching 29. So that will be your reproduction number. It also indicates that over the span of 6 hours, the CO2 levels could accumulate up to 3,976 parts per million. Of course, it's very alarming, and basically it's telling you that you're breathing in someone else's air. So what to do? What are the lists of intervention? So first and foremost is the elimination. So if you're actively tracking all of the cases, so whether they're symptomatic or asymptomatic, you'll be eliminating the risk of infection after. So if you assure that there are no infected person within that classroom, then the risk is minimal. So you have eliminated the risk. Another layer then is to also monitor those symptomatic. So you provide disease monitoring, you isolate those symptomatic. Uh, Therefore, you eliminate the case of the coughing cases, and you'll be dealing with either the breathing cases or the speaking cases. So when dealing with the speaking cases, of course, we cannot simply track that without the use of testing. So in the absence of testing, we could use the other layers of intervention to augment this shortcoming. So the following layer of intervention is what's called engineering control. So in the engineering controls, it involves ventilation and filtration. So in ventilation, first, like I mentioned, you install exhaust fans. So for example, there are two exhaust fans within the classroom, and we're just assuming cloth mask as of now. So that these two fans introduces uh, a flow rate of 0.985 meter cube per second, and the reduction of the risk from almost 29, the reproduction number reduces to 5.4. If we further improve on that, for example, we install two purifiers. So from 5.4, it reduces to 4.4. And other than that, we now use the other layers of intervention, particularly administrative intervention. So what are you gonna do in administrative intervention? You control how the people behave within the classroom, or you control other parameters such as the number of occupants or social distancing, for example, the duration of stay within the classroom. So if we reduce, for example, the number of occupants to be, instead of 30, we reduce that to 24, the reproduction number decreases, and also the CO2 level also decreases. So if you resume that to 30, for example, another administrative intervention is to reduce the duration of stay within the classroom. So you reduce that to 4. So you'll notice that the CO2 levels decrease. So let's look back again. So from 15% probability of infection and a reproduction number of 4.4, if I reduce that to 4, it reduces to 3. If I reduce that, for example, to 2, it reduces to 1.5. So that's how you do administrative interventions. And finally, down the list are the personal protective equipment. So take note that cloth mask is basically that something that doesn't contribute to the reduction of the risk. So you may equate that to in wearing no mask at all. So there are no protections offered. In surgical mask, there is 50% reduction. So you may notice that the risk from 3, it reduces to around 0.78. If we improve further, for example, KN95 mask, it reduces to 0.2. And if we go for N95 mask, it further reduces to 0.0087. So those are the list of interventions that you can employ in ensuring that your classrooms will be safe. hopefully this tool will be useful for you and this will be available for all. That will be all. Thank you very much.